right, so we're on the second part of this set of notes. So once again, if you are not able to print this, just have a spiral or a notebook and just keep it organized. And so you can be adding in the pieces that go with the information today, especially when we start getting to some of those math pieces and those problem solving pieces. You're going to want to have that. So, all right. So first thing, reading the periodic table. Well, in Schoology, you need to go over there and you'll find the periodic table we use in this class. We all use the same one. This is the one that we've worked on as a science department, and Mrs. Peachy has created this particular periodic table, and it's very good. And so you're going to need this. You're going to use this a lot. I highly encourage you to try and print this if you can. And so maybe a couple of copies. And you are going to want the front and the back, but you probably won't need the back for a bit. So the front is really the most important part right now. So make sure you have that. So first thing says, reading the periodic table, it says number one, atomic number. And then you have a blank there. It says the number of blank in the nucleus. So the atomic number is going to be the number of protons in the nucleus. So if you're trying to figure out how many protons are in, let's say, some sort of element that you don't know, you just find the element, you find the atomic number, and that's a proton. So let's go ahead and do that. We'll go over here, and we can take a look at random element. Let's take a look right here at nickel. There's nickel. Top number on the very top. That's the atomic number. So your top number is your atomic number, and that's your proton. So right there on top of nickel, it's got 28 on top. So that means it's going to have an atomic number of 28. It also has 28 protons. And so that's how you would figure that out. So it says the atom of each element contains a unique positive charge in the nucleus. So in the previous notes, we learned that protons were plus ones. So if we look at nickel, it has 28 plus 1. So it has a positive 28 in its nucleus. If you look, copper's 29, cobalt's 27. Nothing else is 28. So the reason that a piece of nickel is because it has 28 protons, or 28 plus 1s. If it had 29, your nickel would now become copper. So this top number is unique to all of these elements. If you have 79, so you have gold. And so that number is unique. And so we want to keep that in our mind as we're going through this, that there's never an overlap for that atomic number or those protons. So B, right here, says an atom's blank comes from the number of protons in its nucleus. An atom's identity, its identity. What element do I have? Well, the identity of my element is based upon that number. So, I have 28 protons, I have nickel. I have 13 protons, I have aluminum. All right, now, if you go down to C, it says it is the blank number in an element block on the periodic table. So the element block is a square on the periodic table. So here's back to nickel. So this is the block. So it's the top number. See the very top number? Sometimes it's off center, so it might be to the right or the left, but on our periodic table, the top number is the atomic number. So it's that top number. So we want to make sure that we've got all that information down. The top number is what you fill in that blank. And once again, if you use a notebook paper or something, you can just write those. Like you could just write 1, and then you could put the number of protons. So that's your blank. And you could just write them out, and you could refer back to this. So, okay. Atoms, the word atom, when you see the word atom, it means that the element does not have a charge. It means that it is neutral, meaning that it has 28 plus ones and 28 minus ones. And so atoms are a little easier for us because they don't have charge. And this is an important thing on A. Atoms, which don't have charge, have the same amount of protons as they have electrons. So if we want to figure out how many electrons an atom of nickel has, well, it has 28 plus ones, so it needs 28 minus ones. And so we learned that the minuses are electrons. So if I got 28 plus ones, I need 28 minus ones to cancel them out. And so if it's an atom, then those are going to be the same. Okay, now that we've kind of looked at the periodic table, this is kind of a fun thing I do in class where you can create a word from the periodic table. A lot of times you can create your name. So it says, write out a fun school-appropriate word using the periodic table. So have some fun with it. Pause the video at this point. Go and create a name. Maybe try to spell your name, your first name or your last name. I've always wanted to do this because that'd be kind of cool to put on my door or whatever, because I'm a chemistry teacher. But you'll look, my first name is Jay, J-A-Y. You're going to have a real hard time finding a J on the periodic table. And then my last name, R-E-E-S-E, that also doesn't work because you can't get the E by itself. And so my first and last name don't work, but there's definitely something that you could spell out for yourself. So like I said, we're going to we'll pause the video, let you go do that, and then come on back. All right. Hopefully you did that. You paused it. You made an awesome word. Don't cheat. Don't look it up on the internet because you're not getting any points for it. It's just kind of a cool, fun thing to do. And so you've got your word there, and hopefully you spelled out something cool. And so it says, how many protons are in your word? So you would just add up the top number. So let's say that you were using the think that I had above there. You'd take 90 plus 53 plus 7 plus 19. And so you'd add all those up, and you would get your total number of protons. And so it's just, get out your handy calculator. You're going to add them all up. You're like, okay, here we go. And you add them all up, and so you get 169 if you added all of those up. All right. So anyway, just kind of a fun thing. Obviously, a little more fun if we're in school, so I can see everybody's. But it's kind of a cool thing. So, all right, let's take a look at ions here. Ions. So we had atoms up here, right? Atoms, no charge. They don't have charges. Now we got ions. Ions do have charges. So think about it. If your pluses and your minuses are canceling in an atom, they're not canceling in an ion. So in ions, what happens is that you have either too many electrons or not enough. But we can never change the proton. So take a look right here. It says created when an atom gains or loses an electron. Only an electron. All right, so gains or loses an electron. And so the reason that that's important is because if you start changing protons, you're just going to change the element. So if I took nickel and I changed its protons, I'm going to turn it into something else. Like if I took one away, I turn it into cobalt. So you never mess with protons, only electrons. So if nickel has 2 less electrons, so it has 26 electrons and 28 protons, it would have a +2 charge because it would have 28 pluses and 26 minuses. 28 minus 26 would be +2. And we'll do some of that math here in a bit. But right here on B, it says when an atom gains an electron, so it's gaining a -1, it has a negative charge, and we call it an anion. So when an atom gains an electron, it has a negative charge, and we're going to call that an anion. When an atom loses an electron, it gets a positive charge because, see, now it doesn't have as many minuses. So if it loses a minus, it has a plus charge. So when an atom loses an electron, it has a positive charge, and we call it a cation. And so then there's your fun graphic over there. There's your cation right there. And see, it's a cat. and it's an ion. So cation, if you look down there, how do we remember a cation is positive? Well, because cats have pause, right? So it says right there, number one, an ion with a positive charge. Now that's silly, but we use a lot of silly stuff in here to help you remember stuff. So the cats have pause, so positive. That's how you remember the cation. So, all right, gonna take a look at this picture here. Let me scroll this up a bit. There's your awesome cation. Okay, so there's the anion and cation. Now notice that the anion in this picture over here, the anion is bigger. See, it has more electrons, so it gets bigger. Cations are smaller because they lost electrons, and the electrons determine how big your atom is. And so this gives you a couple ideas. So over here we had 9 protons and 9 electrons. And with 9 protons, 10 electrons, it has a -1 charge. And then the sodium went from 11 and 11 to 11 protons and 10 electrons. So it ends up with a positive charge. Now, we're going to do all that math here in a minute, so don't worry about it. Just make sure you have those notes down. So, guys, I'm going to pause the video now because